Life on Earth is remarkably resilient. While individual humans rarely live beyond a century, other organisms can survive for millennia. Some trees were already ancient when the pyramids were built. Certain marine creatures were alive before the Roman Empire existed. A few organisms have survived since the last ice age, witnessing the entire span of recorded human history and beyond. These aren't fossils or preserved remains. These are living organisms that continue to grow, reproduce, and adapt. They've survived climate changes, natural disasters, diseases, and human expansion. Their longevity raises profound questions about aging, survival, and what allows certain life forms to endure while others perish quickly. Some have slow metabolisms that delay aging. Others possess remarkable DNA repair mechanisms. Many simply exist in environments so harsh or remote that threats rarely reach them. This is 31 oldest living things on the planet, ranked from the merely ancient to the incomprehensibly old. These organisms were alive long before your great-grandparents, before nations formed, before written language existed. Some were already old when Jesus walked the earth. A few predate all of human civilization. Let's explore Earth's most ancient living residents and discover what allows them to survive across millennia. Number 1. Jonathan the tortoise, 192 years old. Jonathan, a Seychelles giant tortoise living on the island of St. Helena, is the world's oldest known living land animal at approximately 192 years old. Born around 1832, Jonathan was already 50 years old when the first photograph of him was taken in 1882. He's lived through the reigns of 39 British monarchs and has seen the invention of the telephone, airplane, internet, and smartphone. Jonathan is blind from cataracts and has lost his sense of smell, but he remains relatively healthy for his age. He lives on the grounds of the governor's mansion and has become a celebrity, even appearing on local currency. Giant tortoises can live so long partly because of slow metabolisms and lack of natural predators on their home islands. Jonathan's longevity demonstrates that some animals can live multiple human lifetimes, witnessing vast historical changes. He's currently cared for by veterinarians who ensure he remains comfortable in his extraordinary old age. Number 2. Ming the clam, 507 years old when discovered. Ming was an ocean quahog clam discovered off the coast of Iceland in 2006. Scientists determined its age by counting growth rings in its shell, similar to tree rings. Ming was 507 years old when researchers accidentally killed it during the aging process. Born around 1499, Ming was alive during the Ming dynasty in China, hence its name. Ming's discovery revealed that some mollusks can live far longer than previously thought. Ocean quahogs grow extremely slowly in cold waters, and this slow metabolism may contribute to longevity. Ming lived through the entire age of exploration, the Renaissance, the Enlightenment, the Industrial Revolution, both world wars, and into the Internet age, all while sitting on the ocean floor. The accidental killing of such an ancient creature raised ethical questions about scientific research on potentially ancient organisms. Ming reminds us that extraordinary age can exist in unexpected forms beneath the waves. Number 3. Greenland shark, up to 512 years old. Greenland sharks are the longest living vertebrates known to science, with one individual estimated at 392 years old, though some may live beyond 500 years. These sharks grow extremely slowly in the frigid Arctic waters, reaching sexual maturity only after 150 years. Their longevity was discovered through radiocarbon dating of eye lens proteins. These sharks live in deep, cold waters where metabolism slows dramatically, potentially explaining their exceptional lifespan. They're also nearly blind due to parasites that attach to their eyes, yet they survive and thrive. The oldest Greenland shark discovered would have been born around 1505, making it older than Shakespeare. These sharks demonstrate that extreme longevity exists in vertebrates under the right conditions. Their discovery changed understanding of how long vertebrates can potentially live and raised questions about what biological factors enable such extraordinary lifespans. Number 4. Antarctic sponge, over 1,500 years old. Certain Antarctic sponges are estimated to be over 1,500 years old, making them among Earth's oldest living animals. These sponges grow extremely slowly in the freezing waters around Antarctica, adding perhaps only a few millimeters per year. The harsh environment and slow growth contribute to their longevity. Sponges are simple organisms without brains, nervous systems, or organs, which may contribute to their ability to live so long. They filter nutrients from water and can regenerate damaged tissue remarkably well. An Antarctic sponge alive today would have existed during the fall of the Roman Empire and witnessed the entire medieval period. These organisms show that extreme environments don't necessarily shorten life. Sometimes they extend it by slowing metabolism and reducing threats. Antarctic sponges are vulnerable to climate change, warming polar waters, potentially ending millennia-long lives. Number 5. Black coral, over 4,265 years old. Black coral specimens found in deep waters off Hawaii have been dated to over 4,265 years old, making them among Earth's oldest individual animals. These corals grow incredibly slowly in deep, cold ocean environments. Unlike reef-building corals, black corals live in depths where light doesn't penetrate, growing in complete darkness. Black coral's skeleton is composed of protein and chitin rather than calcium carbonate, giving it the black color prized in jewelry, a trade that threatens these ancient organisms. A 4,000-year-old black coral was alive when the pyramids were being built in Egypt and has lived through the entire span of recorded human history. These corals demonstrate that some organisms can survive for millennia in stable, deep ocean environments where threats are minimal and growth is extremely slow. Their age is determined by radiocarbon dating of growth rings, similar to tree ring dating. Number 6. Glass sponges, thousands of years old. Glass sponges, particularly those in deep Antarctic and Arctic waters, can live for thousands of years. Some specimens are estimated at over 10,000 years old, though dating them precisely is difficult. These sponges are built on silica skeletons that give them a glass-like appearance and exceptional durability. Glass sponges exist in environments with minimal disturbance, slow growth, and few predators. Their simple biology and ability to regenerate help them survive for millennia. A 10,000-year-old glass sponge would have begun life at the end of the last ice age, before agriculture, before cities, before any recorded human history. These organisms challenge our understanding of what determines lifespan and demonstrate that some of Earth's simplest creatures are also its most enduring. Climate change threatens even these deep-sea organisms as ocean temperatures and chemistry change. Number 7. Welwitschia plant, up to 2,000 years old. Welwitschia mirabilis, a bizarre plant found in the Namib Desert of Namibia and Angola, can live for over 2,000 years. The plant has only 2 leaves that grow continuously throughout its life, becoming tattered and twisted by desert winds. Some specimens are estimated at over 1,500 years old, with the oldest potentially reaching 2,000 years. Welwitschia survives in one of Earth's driest environments by absorbing moisture from coastal fog through its leaves. The plant's extremely slow growth and adaptation to harsh conditions enable its longevity. A Welwitschia that's 2,000 years old was alive during the Roman Empire and has survived in the harsh desert through droughts, climate fluctuations, and environmental changes. These strange plants demonstrate that extreme longevity isn't limited to trees. Even non-woody plants can survive millennia under the right conditions. Number 8. Liaojian mountain giant sequoia, over 2,000 years old. While not as old as some other sequoias, individual giant sequoias in China's Liaojian Mountains are estimated at over 2,000 years old. These massive conifers can reach enormous sizes and live for millennia in suitable conditions. Giant sequoias have thick, fire-resistant bark and grow in mountain environments with relatively few threats. These trees were already ancient when the Roman Empire was at its height. They've survived forest fires, droughts, windstorms, and climate fluctuations through remarkable resilience. Giant sequoias demonstrate how trees can achieve extraordinary ages through a combination of size, protective adaptations, and favorable environments. Their longevity provides living records of climate history preserved in growth rings. These ancient trees face modern threats from climate change, altered fire regimes, and human activity that their millennia of survival may not prepare them for. Number 9. Olive tree of Vouvs, over 2,000 years old. The olive tree of Vouvs on the Greek island of Crete is estimated at over 2,000 years old, possibly between 2,000 and 4,000 years. The exact age is uncertain because the tree's heartwood is missing, making traditional ring counting impossible. The tree still produces olives used to make oil for ceremonial purposes. This ancient olive tree would have been alive during classical Greek civilization, and possibly during the Bronze Age Minoan culture. Olive trees can live for millennia in Mediterranean climates, surviving through drought tolerance and the ability to regenerate from damaged trunks. The Vouvs olive is celebrated as one of the world's oldest trees and has become a symbol of Cretan heritage. Its survival through thousands of years of human history demonstrates how cultivated trees can achieve exceptional longevity when protected and valued by communities. Number 10. Alerce tree, over 3,600 years old. The Alerce tree, also called Patagonian cypress, in Chile's Alerce Costero National Park is estimated at over 3,600 years old based on core samples. Named Gran Abuelo or great-grandfather, this conifer has survived in temperate rainforests of southern Chile since before ancient Greece existed. Alerce trees grow extremely slowly in cool, wet conditions, producing very dense wood highly resistant to decay. This tree was already over 1,000 years old when the Roman Empire was founded. It has survived earthquakes, volcanic eruptions, and climate fluctuations across millennia. The Alerce's discovery demonstrates that extremely old trees exist not just in California, but also in South America's temperate forests. These trees are threatened by logging and climate change, putting millennia of survival at risk. Number 11, Langurneo yew, 4,000 to 5,000 years old. The Langurneo yew tree in the churchyard of St. Dygon's Church in Wales is estimated at 4,000 to 5,000 years old. Yew trees are notoriously difficult to age because they often become hollow with age, losing the heartwood needed for ring counting. The Langurneo yew is massive and has been estimated through various dating methods. This tree was alive during the Bronze Age, possibly before Stonehenge was completed. It has grown through the entire span of British history, from ancient Celts through Roman occupation, medieval times, and into the modern era. Yew trees were sacred to ancient peoples and often planted in churchyards, which ironically protected them from cutting. The Langurneo yew demonstrates how cultural protection can enable trees to survive for millennia. This ancient tree is now protected as a living monument to continuity and endurance. Number 12, Fordingal yew, 3,000 to 5,000 years old. The Fordingal yew in Perthshire, Scotland, is estimated at 3,000 to 5,000 years old, making it potentially the oldest tree in Britain. Like other yews, precise dating is difficult due to its hollow trunk. Victorian tourists took pieces of the tree as souvenirs, damaging it, but protective walls now surround it. If the Fordingal yew is truly 5,000 years old, it predates Stonehenge and has lived through the entire span of British history. Yew trees can achieve exceptional ages through their ability to regenerate from damaged branches and their toxic compounds that protect against disease and herbivores. This tree is celebrated in Scottish culture and has been protected for generations. The Fordingal yew represents living history, a connection to Bronze Age Britain that still grows today. Number 13, Prometheus tree, 4,900 years old when cut down. Prometheus was a Great Basin bristlecone pine in Nevada that was 4,900 years old when it was cut down in 1964 by a researcher who didn't realize its exceptional age until after felling it. The tree was the oldest known non-clonal organism at the time of its death, and its destruction remains controversial. Prometheus was alive when the pyramids were being built in Egypt and survived through the entire span of recorded human history. Bristlecone pines achieve exceptional ages through slow growth in harsh, high-altitude environments where competition and disease are minimal. The loss of Prometheus highlights the irreversible nature of destroying ancient organisms and led to greater protection for bristlecone pines. Its wood remains preserved and continues to provide climate data from nearly 5,000 years ago. Number 14, Methuselah tree, 4,853 years old. Methuselah is a Great Basin bristlecone pine in California's White Mountains, confirmed at 4,853 years old through ring counting. It's the oldest known non-clonal tree, though its exact location is kept secret to protect it from vandalism. Methuselah was a seedling around 2,831 BC, during the time of ancient Egypt's early dynasties. This tree has survived through extreme conditions, harsh winters, scorching summers, high winds, and minimal rainfall in the White Mountains alpine environment. Bristlecone pines grow so slowly that their dense wood is extremely resistant to decay, disease, and insects. Methuselah provides a nearly 5,000-year climate record through its growth rings, offering invaluable data for understanding historical climate patterns. The tree continues growing today, adding rings that will record our current era for future scientists. Number 15, an unnamed bristlecone pine over 5,000 years old. In 2012, researchers discovered a bristlecone pine in the same California mountains as Methuselah that's even older, over 5,000 years old. The exact age and location are kept confidential to protect the tree. This tree was already growing when humans were inventing writing and building the first cities. This unnamed bristlecone is now the oldest known non-clonal tree on Earth. Like Methuselah, it survives in harsh, high-altitude conditions that eliminate most competition and threats. These ancient bristlecones challenge assumptions about maximum tree lifespan and demonstrate that some organisms can survive not just centuries, but 5 full millennia. The tree's existence raises questions about how much longer it might live and whether even older trees await discovery. Number 16, Sarvia barca cypress, 4,000 to 5,000 years. The Sarvia barca, a Mediterranean cypress in Yazd province, Iran, is estimated at 4,000 to 5,000 years old, making it potentially the oldest tree in Asia. The tree is a national monument in Iran and is mentioned in Persian literature and culture. Its exact age is debated, but it's certainly ancient. If this cypress is truly 5,000 years old, it predates Persian civilization and has grown through the entire history of the region, from ancient Mesopotamia through the Persian Empire, Islamic conquest, and into modern Iran. The tree is protected and revered as a living monument. Mediterranean cypresses can live for millennia in suitable conditions, and the Sarvia barca demonstrates that extreme tree longevity isn't limited to bristlecone pines or sequoias. Number 17. Jaman-sugi cedar, 2,170 to 7,200 years old. Jaman-sugi is a massive cryptomeria tree on Yakushima Island in Japan. Its age is disputed, with estimates ranging from 2,170 to 7,200 years. The tree's hollow trunk makes accurate ring counting impossible, and estimates vary based on different dating methods. Even the conservative estimate makes it one of Japan's oldest trees. Jaman-sugi is named after the Jaman period of Japanese prehistory, which the tree may have witnessed. The tree survives in the wet forests of Yakushima, where heavy rainfall and isolation protected it from logging. Jaman-sugi has become a symbol of Japan's natural heritage and is protected within a national park. Thousands of tourists visit annually via a challenging hiking trail. Whether 2,000 or 7,000 years old, this tree represents living continuity with Japan's ancient past. Number 18. Senator tree, 3,500 years old until 2012. The senator was a bald cypress tree in Florida that was 3,500 years old until it was destroyed by fire in 2012, likely started accidentally by a visitor. The tree was 118 feet tall and a major tourist attraction. Its destruction was mourned as the loss of an irreplaceable ancient organism and a piece of Florida's natural heritage. The senator was alive when ancient civilizations were flourishing in Egypt and the Mediterranean. It survived hurricanes, droughts, and environmental changes for over 3 millennia, only to be destroyed by human carelessness in minutes. The tree's loss highlights the vulnerability of ancient organisms to modern threats and the tragedy of destroying what took millennia to create. A clone of the senator has been planted near the original site, but it will take thousands of years to replace what was lost. Number 19. Jurupa oak, over 13,000 years old. The Jurupa oak in California's Jurupa Mountains is a clonal colony of Palmer's oak estimated at over 13,000 years old. This plant reproduces clonally, with new stems emerging from an ancient root system while old stems die. The entire organism has survived since the end of the last ice age, making it one of Earth's oldest living things. Unlike individual trees that die as complete organisms, clonal colonies can achieve extraordinary ages by continually regenerating. The Jurupa oak's root system has survived climate changes, droughts, and fires for over 13,000 years, while surface stems have died and regrown countless times. This ancient plant was already old when humans were developing agriculture and building the first civilizations. Clonal organisms like the Jurupa oak demonstrate that life can persist for tens of thousands of years through regeneration and adaptation. Number 20. King's Lomatia, over 43,000 years old. King's Lomatia is a clonal plant in Tasmania, Australia, estimated at over 43,000 years old. The plant is sterile and reproduces only through cloning, with new stems sprouting from roots. Genetic analysis suggests all King's Lomatia plants are part of a single ancient clone that has survived since before modern humans left Africa. This ancient organism was alive during the last ice age when Australia's climate and ecology were dramatically different. King's Lomatia has survived through climate changes that eliminated countless other species. The plant's survival demonstrates that clonal reproduction can enable life to persist for tens of thousands of years. However, being sterile and unable to reproduce sexually, King's Lomatia cannot adapt to changing conditions through evolution, making it vulnerable to rapid climate change it has never encountered. Number 21. Pando aspen colony, estimated 80,000 years old. Pando, also called the Trembling Giant, is a clonal colony of quaking aspen trees in Utah, estimated at approximately 80,000 years old, though some estimates range from 14,000 to 1 million years. The colony consists of over 47,000 genetically identical stems connected by a single root system covering 106 acres and weighing approximately 6 million kilograms. If Pando is truly 80,000 years old, it has survived multiple ice ages and climate changes while continually regenerating new stems as old ones die. The colony may be the world's oldest and heaviest organism. However, Pando is currently declining due to overgrazing by deer and elk that prevent new stems from maturing. This ancient organism that survived ice ages may not survive modern ecological imbalances caused by human activity. Pando demonstrates that even the oldest and largest organisms are vulnerable when ecological conditions change. Number 22. Posidonia seagrass, up to 100,000 years old. Posidonia oceanica, a seagrass meadow in the Mediterranean Sea near Ibiza, has been estimated at up to 100,000 years old based on genetic analysis and growth rates. This clonal organism spreads extremely slowly across the seafloor, with individual meadows representing single ancient clones. If this estimate is accurate, the seagrass predates modern humans and has survived through the last ice age and numerous climate changes. Mediterranean seagrass meadows are critical habitats supporting diverse marine life and protecting coastlines from erosion. The discovery that some meadows are so ancient highlights the importance of protecting them from damage by boats, pollution, and coastal development. An organism that has survived for 100,000 years can be destroyed in moments by human activity. These ancient seagrass meadows represent living connections to the Pleistocene epoch. Number 23, Antarctic moss, over 5,500 years old. Antarctic moss banks have been found to be over 5,500 years old based on radiocarbon dating. These mosses grow extremely slowly in the harsh Antarctic environment, adding perhaps a few millimeters per year. The ancient moss banks preserve climate records and demonstrate remarkable survival in one of Earth's most extreme environments. Antarctic moss survives through freeze-thaw cycles, extreme cold, high winds, and minimal moisture. The slow growth and cold preservation allow moss banks to persist for millennia. A 5,500-year-old moss bank began growing during ancient Egypt's early dynasties and has survived through climate fluctuations while recording environmental changes in its layers. Climate change is now threatening Antarctic ecosystems, potentially ending millennia of survival for these ancient moss banks. Number 24, deep-sea tube worms, hundreds of years old. Deep-sea tube worms living near hydrothermal vents can live for hundreds of years, with some individuals estimated at over 250 years old. These worms grow extremely slowly in the deep ocean environment and rely on symbiotic bacteria for nutrition rather than eating conventionally. The extreme environment, high pressure, no light, toxic chemicals, requires adaptations that may contribute to longevity through slow metabolism. Tube worms discovered in the 1970s near hydrothermal vents revolutionized understanding of deep-sea life. Some individuals alive today began life in the 1700s and have survived in complete darkness at crushing pressures for centuries. Deep-sea organisms demonstrate that extreme environments don't necessarily shorten life, and may actually extend it through slow growth and reduced cellular damage. Number 25, orange ruffy fish, up to 149 years old. Orange ruffy, a deep-sea fish caught commercially, can live up to 149 years. This exceptional longevity for a fish is due to life in the cold, deep ocean where metabolism slows dramatically. Orange ruffy grow extremely slowly and don't reach reproductive maturity until around 30 years old. The discovery of orange ruffy's longevity came too late. Commercial fishing had already devastated populations by catching fish that were decades or even a century old before they could reproduce. An orange ruffy caught in 2000 might have been born in the 1850s during the Victorian era. The species demonstrates how fishing can unknowingly destroy ancient individuals when we don't understand their age. Orange ruffy populations have not recovered from overfishing, and the species highlights the vulnerability of long-lived marine species to exploitation. Number 26, lake sturgeon, over 150 years old. Lake sturgeon, large freshwater fish native to North America, can live over 150 years. These ancient fish were once abundant but were overfished for caviar and meat. Some individuals caught in recent decades were over a century old, born in the 1800s. Lake sturgeon grow slowly and don't reproduce until age 15 to 25, making populations vulnerable to overfishing. Their longevity was not understood when intensive fishing began, leading to population collapses. A 150-year-old sturgeon alive today would have hatched during the American Civil War era. These fish demonstrate how freshwater species can achieve exceptional longevity and how human activity can devastate populations of long-lived species before we understand their biology. Conservation efforts are slowly helping sturgeon populations recover. Number 27, bowhead whale, over 200 years old. Bowhead whales can live over 200 years, making them the longest-lived mammals. Evidence includes stone harpoon points from the 1800s found embedded in whales caught recently, indicating those individuals survived whaling attempts over a century earlier. Genetic studies suggest bowhead whales may live even longer than 200 years. Bowhead whales survive in Arctic waters with slow metabolisms, large body sizes, and possibly exceptional DNA repair mechanisms that prevent cancer and aging. A bowhead whale alive today might have been born in the early 1800s, before photography was invented. These whales demonstrate that mammals can live far longer than previously thought under the right conditions. Understanding what allows bowhead whales to live so long while avoiding age-related diseases could inform human aging research. Number 28, Red Sea Urchin over 200 years old. Red sea urchins on the Pacific coast can live over 200 years, with some individuals estimated at 200 years or more based on growth rates. These echinoderms show few signs of aging. Even centuries-old individuals remain reproductively active and healthy, exhibiting what scientists call negligible senescence. Red sea urchins grow extremely slowly and continuously throughout their lives. They show remarkable resistance to disease and cellular damage even at advanced ages. A 200-year-old sea urchin was born during the Napoleonic era and has lived through the entire industrial age. These animals interest aging researchers because they don't seem to deteriorate with age like most animals. Understanding why sea urchins don't age in conventional ways could reveal mechanisms for extending healthy lifespan. Number 29, Geoduck clam over 168 years old. Geoduck clams, large burrowing clams native to the Pacific Northwest, can live over 168 years. These unusual clams have long siphons that extend from their buried shells to the surface. They grow slowly and can reach substantial sizes over their long lives. Geoducks were not understood to be long-lived until aging studies revealed individuals over a century old. These clams were burrowing in seafloor mud during the American Civil War and have remained in the same spot for over a century. Their longevity is attributed to life in stable, cold environments with slow metabolism. Geoducks are commercially harvested, and understanding their age has led to debates about sustainable fishing practices for such long-lived species. Number 30, Aldabra giant tortoise, over 150 years old. Aldabra giant tortoises from the Seychelles can live over 150 years, with several documented individuals exceeding 150 years. These are among the longest-lived vertebrates on land. Adwaita, an Aldabra tortoise that died in 2006, was estimated at 255 years old, though this age is debated. Giant tortoises achieve longevity through slow metabolism, lack of natural predators on their island homes, and physiological adaptations. An Aldabra tortoise alive today at 150 years old would have hatched during the American Civil War and lived through both world wars, the space age, and the digital revolution. These tortoises demonstrate that reptiles can achieve remarkable longevity and that island species with few threats can live multiple human lifetimes. Number 31, Tuatara over 100 years old. Tuataras, reptiles endemic to New Zealand that resemble lizards but are actually the last surviving members of an ancient reptile order, can live over 100 years. Henry, a tuatara at the Southland Museum, is estimated at over 120 years old and fathered offspring at age 111, demonstrating reproductive vigor at advanced age. Tuataras have exceptionally slow metabolisms, growing slowly and living long lives. They are sometimes called living fossils because their order existed during dinosaur times and they've changed little over millions of years. A tuatara over 100 years old was born in the Victorian era and has survived through the entire modern period. These reptiles demonstrate that members of ancient lineages can achieve impressive individual longevity. Tuataras are protected in New Zealand, and understanding their longevity contributes to conservation efforts. So there you have it, 31 of the oldest living things on the planet, ranging from nearly 200-year-old tortoises to potentially 100,000-year-old seagrass meadows. These organisms challenge our understanding of aging, survival, and the limits of life itself. While humans rarely live beyond a century, these creatures and plants demonstrate that life can persist for millennia under the right conditions. What unites many of these ancient organisms is not just longevity but resilience. They've survived climate changes, natural disasters, and environmental shifts that eliminated countless other species. Some survive through slow growth that minimizes cellular damage. Others possess remarkable abilities to repair DNA or regenerate damaged tissues. Many exist in extreme or stable environments where threats are minimal. These ancient organisms also provide invaluable scientific information. Tree rings record centuries of climate data. Deep-sea creatures reveal how life adapts to extreme conditions. Long-lived animals help researchers understand aging mechanisms and potentially how to extend healthy lifespan. Every ancient organism is a living library containing information accumulated over centuries or millennia. Tragically, many of Earth's oldest living things are now threatened by climate change, habitat destruction, and human activity. Organisms that survived ice ages may not survive the rapid environmental changes humans are causing. Ancient trees are cut down, old-growth forests cleared, and long-lived marine species overfished before we understand their biology. We're destroying in decades what took nature millennia to create. Protecting these ancient organisms should be a priority not just for their scientific value, but because they represent irreplaceable living connections to the past. A 5,000-year-old tree connects us directly to the Bronze Age. A 10,000-year-old sponge links us to the end of the Ice Age. These organisms witnessed human civilization's entire development and deserve our protection and respect. Which ancient organism amazed you most? Did any of these ages seem almost unbelievable? What do you think we can learn from organisms that survived for centuries or millennia? Share your thoughts in the comments below. If you found this exploration of Earth's oldest living things fascinating, please like this video and subscribe to our channel for more content about nature, science, and the remarkable diversity of life on our planet. Thank you for watching, and remember, some of the organisms sharing our planet are incomprehensibly old living connections to eras long before recorded history. They deserve our protection and wonder.